Hi, this is Julie Harland. Please visit my website at yourmathcal.com where I organize my videos by topic. A fraction that contains one or more fractions in either its numerator or denominator or both is called a complex fraction. So below are 5 examples. The first example, we have 3/4 over 5/8, so it has a fraction in the numerator and a fraction in the denominator. The second one, there's an x alone in the numerator, but in the denominator, there's two terms, 2 minus x over 3, so there's a fraction there. And you can see from the third, fourth, and fifth examples, I have fractions in both the numerator and denominator. Complex fractions are not in simplified form. That means we can simplify further so they don't look complex. And there are two commonly employed methods we could use. And these are a quick overview of the two methods. The first method is to write both the numerator and denominator as single terms or fractions. And then you'll multiply the numerator by the reciprocal of the denominator. The only one in the examples above where you already have the numerator and denominator written as a single term or fraction is the very first one. We have just a single fraction in the numerator, 3/4, and a single fraction in the denominator, 5/8. All of the rest of them are not in that form. If you look at the fourth example, 1 over x minus 2 over x squared in the numerator, there are two fractions in that numerator separated by a subtraction sign. So that's not a single fraction. And in method 2, you don't need to have it in the form as the very first example up here. Instead, to simplify the complex fraction, the first step would be to multiply the numerator and denominator by the least common multiple of all the denominators of all the fractions in the numerator and the denominator. All right, we're going to simplify this complex fraction. So the first thing I'm going to do is put a whole parentheses around this denominator in the fraction that's in the numerator. And I notice I have like a single big fraction in the numerator and a single big fraction in the denominator. So that means I've got the whole numerator divided by the whole denominator. And I'm going to do this in one step. I'm going to write that as what's in the numerator, which is the x over 2x squared plus 11x plus 15. And instead of writing divided by this, I'm going to go ahead and multiply it by the reciprocal in the first step. Just slightly less writing. Okay, so I notice I have a quadratic here. What I'm hoping is that maybe if I factor it, it's going to cancel that 2x plus 5. So you can use any method you want to find the factors of 2x squared plus 11x plus 5. Okay, so go ahead and try that on your own. And I'm going to write down what they are here. It's 2x plus 5 times x plus 3, because if you do the first outer inner last, you'll see you get that. So I'm going to say that can be written in this form. Okay? All right. So now, very nice, I am able to cancel the 2x plus 5 with that 2x plus 5. So what I have left in the numerator is just the x times 1, which is x. In the denominator, I have 1 times x plus 3 times 1. That's simply an x plus 3. So that's using the first method. Now, let's do it the second method. So here's my original problem, x over 2x squared plus 11x plus 15 over 1 over 2x plus 5. Now, we need to find the least common denominator. So I'm going to rewrite the numerator of this big complex fraction as x, but I'm going to write the denominator in the factored form. So again, you would do this on your scratch paper, figure out the factors using any method for factoring, and that would be the same thing as x over 2x plus 5 times x plus 3. And now the denominator, there's only one factor in the denominator of this fraction, so there's nothing to factor, 2x plus 5. And now the second method, you multiply both the numerator and the denominator by the least common multiple of all the denominators, which is 2x plus 5 times x plus 3. So I would multiply the numerator by 2x plus 5 times x plus 3, and I would multiply the denominator by 2x plus 5 times x plus 3. Now if you want, you could write each of those over 1. Okay? And so, and if I want, I can extend this all the way out if that helps you. Okay? So now, can I cancel anything? Yes, that's the whole point of multiplying by the least common multiple of all the denominators. The 2x plus 5 cancels here, and also the x plus 3 cancels. And in the denominator, the 2x plus 5 cancels. So what do I have left in this numerator? I have an x over 1, which is x. And in the denominator, I have x plus 3 over 1, which is just x plus 3. And we get the answer. Personally, when I have a single fraction in the numerator and a single fraction in the denominator, I think it's usually easier to just go ahead and multiply by the reciprocal, but it's up to you. Both methods give you the right answer.